Good morning, students. Today we will discuss the examples based on the first fundamental magnitudes. As we already discussed, the fundamental magnitudes are E, F and G, where E is given by the dot product of vector R1 with itself, and F is given by the dot product of vector R1 with vector R2, and G is given by the dot product of vector R2 with itself. Here R1 and R2, these are the tangential vectors to the given surface, and R1 denotes the partial derivative of vector R with respect to the first parameter, which is u here, and R2 denotes the partial derivative of vector R with respect to the second parameter v. So our first problem is calculate the first fundamental magnitudes for the surface having the position vector of the point given by vector R is equal to u cos v, u sin v, f of u. Here u and v are the parameters. So let us first find the tangential vectors vector r1 and vector r2. Now the vector r1 means partial derivative of vector r with respect to the parameter u. So the partial derivative of u cos v with respect to u, that is cos v. The partial derivative of u sin v with respect to u, that is sin v. The derivative of f of u, which is f dash u. Now the vector r2 means the partial derivative of the vector r with respect to the parameter v. So the partial derivative of u cos v with respect to v, that is given by minus u sin v. Derivative of u sin v with respect to v, that is u cos v, and this is not a function of v, so its partial derivative with respect to v, that will be 0. Now let us find the fundamental magnitudes. First fundamental magnitude E is given by r1 dot r1. It means the dot product of this vector with itself, so that will be cos square v plus sin square v plus f dash square. Cos square v plus sin square v, that is 1. So we get 1 plus f dash square. This is E. Now we find f, which is the dot product of tangential vector r1 with r2. Now r1 dot r2 means cos v into minus u sin v plus sin v into u cos v plus f dash u into 0. So that finally becomes 0. Next fundamental magnitude is G, which is given by the dot product of vector r2 with itself. So r2 dot r2 from here is given by the square of these three coefficients. So that will become u square sin square v plus u square cos square v plus 0 from here. That will become u square, because sin square v plus cos square v, that is 1. So we have obtained E, F and G, which are the first fundamental magnitudes. Now in the second problem, we are to find the fundamental magnitudes E, F, G and also H, which is given by the square root of EG minus F square for the paraboloid having the position vector of the point given by the coordinates u, v and u square minus v square. So this is the position vector of a point on the paraboloid. So again let us find vector r1 means partial derivative of vector r with respect to u. So derivative of u, that will be 1. Derivative of partial derivative of v with respect to u, that will be 0. Partial derivative of u square minus v square, which is 2u. Now vector r2 means partial derivative of this vector with respect to v partially. So derivative of u will be 0. Derivative of v, that will be 1. Derivative of u square is 0. Derivative of minus v square, which is minus 2v. Now E means r1 dot r1. So that is given by the square of 1 plus square of 0 plus 2u whole square. So that will become 1 plus 4u square. In the same way, F is given by r1 dot r2, dot product of these two vectors 1 into 0 plus 0 into 1 plus 2u into minus 2v. So that will become minus 4uv. Now let us find g. G is given by the dot product of vector r2 with itself. So that is given by 0 square plus 1 square plus minus 2v whole square. So that will become 1 plus 4v square. Now h is given by the square root of eg minus f square. Substituting the values of e, f and g here, we get square root of 1 plus 4u square into 1 plus 4v square minus 16 in u square v square. So we have obtained the values. Here this is 4v square, not whole square, 1 plus 4v square. So after simplifying this, we get the value of h, which is given by square root of 1 plus 4u square plus 4v square. So these are the values of the coefficients e, f, g and h. Now the next problem is, show that for the surface of revolution having the coordinates x is equal to u cos v, y is equal to u sin v and z is equal to function of u, the parametric curves form an orthogonal system. Now the parametric curves form an orthogonal system if the fundamental magnitude f that becomes 0. So we have to prove f is 0 for the given surface of revolution, and also we are to find ds square is equal to 1 plus f dash square into du square plus u square into dv square. Here this dash is the derivative with respect to the parameter u. So these coordinates we already discussed in the first problem, and there we've already obtained the values of e, f and g. E in the first problem, that is given by 1 plus f dash square, f is 0 and g is u square. Now because f is 0, so we can say that the parametric curves, they will form an orthogonal system. Now we are to find the value of ds square. Now by definition of first fundamental form, ds square is given by e du square plus 2f du dv plus g into dv square. Now because f is 0, this term will be 0. So we, after substituting the values of e and g here, we get the value of ds square, which is given by 1 plus f dash square into du square plus u square into dv square. Now the next problem is, find E, F, G, H and also the area corresponding to the domain for the anchoring between the limits 0 to 2 pi for the parameters u and v. The position vector of the point on the surface is given by x is equal to b plus a cos u into cos v, y is equal to b plus a cos u into sin v, z is equal to a sin u. Now let us again find the tangential vectors, vector r1 and vector r2. Now vector r1 means partial derivative of this vector with respect to u. Derivative of b is 0. A cos u derivatives will be minus a sin u. Cos v is constant, that will remain as it is. The derivative of this term with respect to u, that will be the derivative of a cos u, that will be minus a sin u. This term is constant, and here the derivative of a sin u, which is a cos u. Now let us find its partial derivative with respect to the parameter v. Derivative of this term, that is constant, so derivative of cos v, which is minus sin v. Here this term is constant, derivative of sin v is cos v. Derivative of a sin u with respect to v partially, that will be 0. So now let us find E. E is r1 dot r1, means square of these three terms and their sum. That will give us the value of E, which is a square. Now value of f, which is given by the dot product of r1 and r2, and we can see that when we take the dot product of r1 with r2, these terms are cancelled out, so we get the value 0. Now G is r2 dot r2, means the square of these three terms and then their sum. that after simplification gives the value of g, which is given by b plus a cos u whole square. Now, in order to find the area, we require the value of h. Now, by definition, h is given by the square root of eg minus f square. Now, the value of e is a square and the value of g is b plus a cos u whole square. The value of f, that is 0. So, from here, after taking square root, we get the value of h, which is given by a into b plus a cos u. Now, elementary area for the point having the coordinate u and v on the given surface is given by h du dv. Therefore, the total area that will be given by the integration of this term with respect to u and v in the given domain. The given domain is having the limits from 0 to 2 pi for u as well as v. So, substituting the value of h here, we have a into b plus a cos u, its integration with respect to v and u. So, firstly let us do the integration with respect to v. That will be 1 integration of 1 with respect to v, that will be v, and after substituting these two limits we get the value 2 pi. Now, let us integrate with respect to the parameter u. Now, b plus a cos u, its integration with respect to u, that will be bu plus a sin u. After substituting the limits from 0 to 2 pi here, sin 2 pi, that is 0, sin 0 is also 0. So, we get the value of area, which is given by 4 pi square into AB. So, this completes the examples based on the first fundamental coefficients.